Recording in progress.
Good evening. I'd like to call the meeting for the Carpinteria Valley Water District to order. Can we have the Pledge of Allegiance, please? Pledge allegiance to the flag, United States of America, to the republic for which it stands, one nation, under God, indivisible, liberty and justice for all. The roll call, please, Lisa.
Director O'Connor?
Here.
Director Holcomb?
Here.
Director Balch?
Here.
Director Roberts?
Here.
Director Van Winkle? 5 present.
Then Kelly, the agenda confirmation, any changes or?
No changes.
Thank you. Then item number 4, public forum. Any person may address the board of directors on any matter within its jurisdiction which is not on the agenda. Lisa, anything? Thank you. Then we got on the consent agenda, there's 3 items, but I like to make them separate if you guys are okay. Item number A, minutes of the meeting of the board held on April 22nd, 2026. If we can have a motion, please.
Move to approve. Second.
We got a motion and a second. Any discussion? Roll call, please.
Director O'Connor?
Aye.
Director Holcomb?
Abstain.
Director Balch?
Aye.
Director Roberts? And Director Van Winkle?
Yes.
Motion passes 3-2. Then
we got item number 5B, consider approval of a customer water bill credit request for account 03030525-10 in the amount of $160.84 pursuant to District Rules 14A 5 related to a leak relief for action. Kelly and Norma.
Yes, directors, this is, we have an established policy that grants leak relief to customers who had a large water bill and responded promptly to repair the leak. We check for evidence that their water use has returned back to normal and have some verification that a repair, that it was addressed. Anything over $150 is required to come to the board for approval. So this is, our recommendation is to approve the request.
Can I have a motion, please?
So moved.
Second.
The motion is second. Any more discussion? A roll call, please.
Director O'Connor?
Aye.
Director Holcomb?
Yes.
Director Balch?
Aye.
Director Roberts?
Aye.
Director Van Winkle?
Yes.
Motion passes 5-0.
Then item number 5C, consider authorizing a contract with Colantano, Highsmith, and Watley PC for water rates, legal services reflecting updated hourly rates. Kelly?
Yes, directors, so this is our existing legal counsel for water rate services. We've used Colantano for several years. Our existing contract was actually executed in 2021, and they've never increased their hourly rate. So after 5 years, there's been substantial increases in costs. So they're requesting an update from $355 per hour to $435 per hour, plus an annual increase thereafter, which would be the lesser of 5% or the CPI for all urban consumers for the Los Angeles area. So we've been pleased with their work and want to continue the contract. We believe there's going to be continued need for the support. It is specialized, and we're recommending approval of the contract. There's no other changes to the terms. It's really just a change in the fee schedule.
How long is the contract for?
There's no expiration at this point. We could negotiate that if there's a desire of the board to have a termination date.
I guess I was just curious with the 5% or CPI increase annually, if that had an end date or just forever until we cancel the contract, I guess?
Correct.
And we don't like re-up it annually or anything? It's just ongoing until either party terminates or something?
Correct. We can add language if there's a desire, but our previous contract was really just ongoing unless a party requested a change to it or wanted to terminate it. So we do have those rights going forward.
Thanks.
Can we have a motion, please?
Holly makes a motion to support the amended contract with the increased rates.
Second.
Got a motion and a second. Any more discussion? Roll call, please.
Director O'Connor?
Aye.
Director Holcomb?
Yes.
Director Balch?
Aye.
Director Roberts?
Aye.
Director Van Wingerden?
Yes.
Motion passes 5-0.
Item number 6, unfinished business, none. Item 7, new business. 7A, consider status update on preparation of the 2025 Urban Water Management Plan and Water Shortage Contingency Plan, and schedule a public hearing for June 24th, 2026 for action. Kelly and Rob Morrow with Water Systems Consulting.
Yes, thank you, Director. So this is something that we have to do every 5 years as an urban water supplier. It's a report required by the state. They release the guidelines, fairly late in the year, and then it's a short turnaround to put the report together and adopt it and submit it by July 1st, but we are on track to do so. We wanted to give a preview to the board of the projected water demand and projected water supply that will feed into all of the tables that are required by the state for the ultimate submittal. We're planning to release the draft report June 8th for public review. So we're currently reviewing it. The staff is reviewing the internal administrative draft, and then that would be posted June 8th and then considered on June 24th for adoption by the board. We'd be able to receive comments in the interim and bring any comments received to the board meeting on June 24th. So it's really a nice, in the end, a nice document. We have one from 2020 that gives a good description of our overall water supplies for anyone wanting to learn about the district and some of the history and background on our water supplies. It's a nice overview document. So Rob Morrow should be online, I believe.
He's there.
And we'll be giving a presentation. Water Systems Consulting has been helping us for a long time and really has a good handle on our water demands and supplies. So we're fortunate to have them helping us with this work. So
I had a quick question. You had said, it's a tight turnaround. I recall that this always is, this one. Okay, thank you.
it is, yeah, the guidelines, Rob knows better than I do the actual date that the guidelines were released, but it's sometime in the spring, and then you have just a couple months.
Guidelines were released in January this year, which is the earliest they've ever been released. So thank you. So we've got a few slides just to go over. First, just going to cover some basics of why we're doing this urban water management plan, and then talk about some of the supply and demand analysis findings. And then some of the water shortage contingency plan is the other component of this that is required to be updated every 5 years. And then I just got a preview of the next steps as far as key dates coming up, and we'll talk about that. So next slide after this. So purpose of the plan, it's required every 5 years for any agency in California that serves more than 3,000 connections or 3,000 acre feet per year. And it's a 25-year projection, looking in 5-year increments. Everything needs to be done by July 1st. And the main stick that's used is requiring this to be in place for grant and loan eligibility. And so that's obviously, with CAP going on, is a key driver for us to get this in on time. Next slide, please. So what we're looking at is long-term water supply during quote unquote normal. That's what comes from the guidance. And as you know, there isn't really a normal year, so it's really a long-term average. And then, so normal conditions and then drought conditions. And we look at a single year and a 5-year drought. And then the other component is looking at all the water efficiency and conservation work, and then water shortage contingency plan, as I noted. Next slide, please. So this 2025 plan is an update to the 2020 plan. So there's a few new requirements, but mainly updating the more recent supply and demand conditions. And the reason we were able to do this pretty efficiently is because most of this is really building on the supply alternatives analysis, which you saw presented to you in December and January. And actually, it's a little more simplified presentation of the information than what you saw. And then also we've incorporated the latest population projections from Santa Barbara County Regional Growth Forecast. Next slide. So the next few slides in this section are going to talk a little bit about demand projections and then compare them with supply. So here you can see your historical demand on the left, the last 15 years. So obviously a general downward trend as conservation really has tightened up, but also ups and downs as the weather changes from wet and dry periods. And so we've got a simple, straight line projection, but obviously year to year, you guys experience variability. And so this 3,800 acre feet per year of existing demand growing to a little bit over 4,000 acre feet at build out is in line with the previous, again, with the supply or the supply alternatives analysis, as well as some of the other work that's been going on in parallel, like rate projections and capital fees. And I think we'll just note that the projections are, everyone's best understanding at this point. As you know, most of the growth would be from infill and some of the regional housing needs. And those happen in kind of chunks. And the timing of those is really hard to predict. So, every 5 years we'll continue to look at where we think we're going. Next slide, please. So then on the supply projections, again, this is similar to what was presented back in January. For groundwater, a long-term average supply of 1,200 acre feet per year. But what's important is in those dry periods is being able to ramp up production when Kachuma water in particular or state water isn't available. So with the two existing wells, it can produce up to 2,900 acre feet per year, roughly. And then once Smiley is implemented, replaced and implemented, you'll be able to produce up to 3,600. Although the caveat there is we don't know the full production until it's actually put in place, and it could be higher, but we went on the lower end there. For Kachuma water, assuming long-term supply at 75% of the current contract value or contract amount, so 2,100 acre feet per year. And then for the state water project, it includes the latest projections from DWR, which is the State Water Project Delivery Capability Report, which is put out every 2 years. And again, this came out. The draft came out in October and was finalized in December, so we had used these numbers previously. But looking at 54% long-term average yield, reducing to about 48% in 20 years with climate change and environmental restrictions in the future. And then the last piece is CAP, the recycled water component, assuming it's fully online in 2029. So you'll see that reflected in the 2030 numbers. Next slide, please. So this is a pretty simplistic view of your supplies over the next 25 years in 5-year increments. You got the groundwater along the bottom. Kachuma project, it's showing, today we've got the 100% of contract, and for the future, we're showing 75%. Obviously, it's not going to change in a step like that over time, but that's what was used for this analysis. And then you see the big chunk of CAP jumping in there, starting in 2030, and then state water project long-term average of 54%, declining to 48%. So a slight decrease over time from the state water project declining. And so obviously you've got more supply than demand in normal years. And as we discussed previously, that what you can use with that is to lower groundwater pumping reduce state water project use, but you're able to build up storage in the groundwater basin to use during droughts. And next slide, please. So, oh, I didn't realize this is a build. Sorry. Yeah, thank you. So we're looking at the supply reliability analysis is looking at a single dry year and a multiple dry year. So on the single dry year, you're in good shape because Kachuma takes a while to react to bigger drought conditions. And so after just a single year of drought, it's in a good shape. But in multiple dry years, that's where CAP really helps. You can see the benefit of CAP where you're able to, again, rest the groundwater basin and you've got 1,000 acre feet of supply during those periods. So the next slide is the single dry year. And go to the next slide, please. Yep. And for the state water project, that's dropping down to a 5% allocation, which we actually experienced 3 times in the last little over 10 years. And whereas your other supplies, Kachuma project, you've got your full allocation, 75% of the current one. You've got CAP, and then groundwater. The amount of groundwater is really just set to meet the rest of your demands. Obviously, how you'd actually operate in that year would be dependent on other factors. And then I also want to note in these drought scenarios, we're not reflecting reduced demand from additional conservation that could happen. And so that's always an option to reduce demand, to reduce the need for the use of supplies. So the next slide is a 5-year drought. And instead of going through every variation of it, I just wanted to show the next 5 years and an example of how this may would play out. And so again, along the bottom, we're showing groundwater, which goes up and down to meet demand. You've got Kachuma water. So this is reflecting the 2014 to 2018 allocations, which was the lowest that have occurred on record. And then state water project is set at 15%, which is for the historical modeling that was done by DWR for a 5-year period is the lowest allocation for a 5-year period. And so that's set at 15%. And then you'll see that before CAP comes online, you're able to the carryover water, which is a combination of some water. It's mostly Kachuma carryover water that would come out of this year. And then there is some of the state water that's in San Luis Reservoir. This is an exercise. Obviously, we're in a little different conditions than entering a 5-year drought right now. We've got a 30% state project allocation. Reservoirs are full, so it's a little different. This doesn't totally reflect reality, but it is the exercise that we're required to go through as part of the urban water management plan. But I think it just shows 2 things: one, how carryover can help, especially at the beginning of a drought, and then 2, once once CAP is involved, how it helps reduce groundwater pumping. Because you can see in 2028, if these conditions have played out, the groundwater pumping gets up to 2,800 or so acre feet per year. And if CAP wasn't in place, it would be approaching that as well for several consecutive years. And then the next slide, I wanted to show the same condition, but excluding state water project. And so mainly, the result of that is the state project would give you about 300 acre feet per year in this situation. And if state water project wasn't being used once CAP's online, you basically would need to increase groundwater pumping by about 300 acre feet under those conditions. Next slide, please. So I guess before I move on, there are similar results looking at 5-year increments going through 2050. And again, when you look at CAP being online for the full period, it allowed less groundwater pumping. So thank you. Next slide, please. So
Before you go on to the next, I've got
Oh,
a
yeah,
quick,
go for it.
quick question
Yep.
on that last slide.
Yeah.
And this is just truly naive on my part. The carryover unused water, sort of above above the total supply line. I've never heard us, in my short tenure, taking action on that unused carryover. Is that an opportunity that's,
Typically, it will just automatically carry over.
yeah,
This year we have quite a bit of state water carryover at San Luis, and so CCWA is looking at potential opportunities to transfer or sell that water because there was a pretty great risk of spill last year.
right?
But it'll just, whatever is not used carries over. Same with the Kachuma project. It's when the lake fills and spills that you lose your carryover balance.
Right. So it's a zero cost reserve, if
Correct.
you will. Okay. Very good. Thanks.
And this is, very conservative because, as Rob mentioned, it's using 2014 to 2018 allocations for Kachuma, which we were already a few years into the drought by then, or dry period. And the lake level was not full at the beginning of 2014 as it is today. So this is a pretty conservative approach, but it does show that we have sufficient supply to meet demands for 5 consecutive dry years.
Thank you.
Good. Well, if you go to the next slide after this, just have 2 short slides on the water shortage contingency plan. If you move to the next one, this is so the water shortage contingency plan really was added to the requirements in 2020, coming out of the mid-aughts droughts. And really it was from the state wanting to have better visibility on what different water districts were doing to be able to understand what kind of position, water supply and demand position they're in, and what kind of actions they plan to take and are allowed to take. So in the 2020, there was it was a big effort to get this in place, and there hasn't been any substantial changes since then. But the intent of it is it's a separate document so that it can be updated, not necessarily every 5 years, but as necessary, and usually after a drought period to implement some lessons learned. The way it's set up is as you guys operate in a drought, you've got stage declarations, and then you've got a menu of options to choose from to reduce demand. And so again, not much or very little has changed since the last one. And on the next slide, we just have the basic breakdown for your drought stages. So the 6 stages here showing an increased reduction as the stages increase, or reduced allotments as the stages increase, but generally similar increases across the different customer types with some exceptions within the agricultural and residential categories. And again, this is a guide. This is guidance and provides you a basic framework for how to manage and report on water shortages within a drought.
Yeah, if I could just expand on
Yep.
that too. So this is a plan. Sometimes things don't actually go as planned. So if we were going into a staged condition with drought, the board would make a decision based on the circumstances at the time. So we'd have to come back with, a separate resolution or action. So this is really just the guidebook, and then what actually occurs, you'd have some flexibility at the time. So, but this is, the state does want everyone to plan for 6 stages of water shortage, and so this, is aligned with how the state looks at these situations.
Yeah, thank you. Is there any questions on that? Not, we'll move to the last slide. So after next steps, so the district staff are currently reviewing. We provided an admin draft a little over a week ago, and they will be providing us feedback here soon, and then we'll be incorporating that and finalizing it so it's issued as a public draft on your website by June 8th. And then your second board meeting in June, we've scheduled to have a public hearing to get additional feedback on the urban water management plan, and it's open for public comment as well. And then at the same hearing, you'll have the option to adopt both of the plans, the urban water management plan and the water shortage contingency plan. And then again, we have that July 1st deadline to submit everything after that. So that's all I have for today. Is there any other questions on earlier content or on the schedule?
Anybody? We're good, thanks, you're up.
Okay, thank you.
Kelly, I got one. I think we already approved the cost of this. Can you remind us what the cost was?
I believe it was $46,000 or $48,000.
That sounds right.
Okay, thank you. So we need a motion to get this finalized, Kelly, or are we good the way it is?
You just need to set the public hearing for June 24th.
Okay,
So moved.
Second.
we got a motion and a second. Any more discussion? Then roll call, please.
Director O'Connor?
Aye.
Director Holcomb?
Yes.
Director Balch?
Aye.
Director Roberts?
Aye.
Director Van Wingerden?
Yes.
Motion passes 5-0.
Then we got item number 7B, consider update from Consumer Operation and Maintenance Board regarding infrastructure improvement projects along Sheffield Tunnel and Pipeline. For information, Kelly, and presented by Joel.
Yes, thank you, directors. And this was something Director O'Connor had requested after attending the last COMB board meeting. And I just wanted to let Janet Gingras is here, the general manager of Kachuma Operation and Maintenance Board, and Bill Carter as well, who's legal counsel. Joel Degner wanted to be here in person today, but he wasn't feeling 100%, so he's going to be joining us online to give a presentation on the Sheffield Tunnel pipeline rehabilitation projects. So, Joel, can you hear us?
Yes, can you hear me?
Okay, great. Yes, we can hear you and see you. Thank you for being here today.
Sorry I couldn't be there in person. I'm just a little under the weather. So I provided this presentation back in February to the Bureau of Reclamation, so you'll see their logo and Combs logo. And this was after we did the Sheffield Tunnel inspection in 2025, April 2025. So they thought it'd be an interesting project to have at their water management workshop as an example of one of the challenges for repairing this older, aging infrastructure. You can go next slide. So I just first off wanted to thank the Carpinteria Valley Water District Board and staff for the 2021 cooperative agreement. So this was huge for Coleman Carpinteria Valley Water District. It was an innovative approach. We repaired 25 of the Carpinteria Valley water laterals coming off the South Coast conduit. And we had to do this so that we could do a Category 1 recommendation, which was to raise our above or below ground air vents above grade. So you can see in the picture on the upper right, that was a below grade air vent. That is a concern because if rainwater gets in there, the pipeline breaks, then the dirty water gets sucked into the potable drinking water system. So reclamation gave us a Category 1 to raise these above grade. And so we were able to raise them outside the manhole vaults out on the side of the road. And this required an inline isolation valve and over 25 line stops. I think both Brian King and I got a little grayer and maybe lost a little hair. It was a stressful period, but it went really well. And so thank you to the board and staff on that. Next slide, Kelly. So the challenge that I presented is, most of the reclamation projects like the Kachuma project are 75 to 100 years old. And the pipelines that were installed are, rated maybe to 7,500 year life. So when we have to go in and repair these big projects, how are we going to do it? They were put in, for the Sheffield Tunnel. It was a football field for the University of California on one side and a ranch on the other. And now I have a tennis club and a nature preserve, so, and then other areas, everything's built in. The water allowed development, but now the development can be a challenge, to repair the water pipeline. So next slide. So just a background on the Kachuma project. It was Reclamation's first project along the coast. It was built from 1950 to 1956. The big components are Bradbury Dam, which forms Lake Kachuma, and the Tecolote Tunnel, which was 6.4 mile long tunnel through the mountains to get the water to the south coast. Next slide. And so here's a map of that. But what's interesting about the system is the water actually starts, in the foothills behind, or the mountains behind Carpinteria. The watershed divide is just, a couple miles to the east of Carpinteria, and then it flows all the way down the San Ynez River, goes to Kachuma, then it does a 180-degree turn, comes all the way back to Carpinteria Valley Water District. And it serves over 10,000 acres of agriculture, serves over 200,000 people. And the current operating yield is 25,714. Of that, Carpinteria has about 10% of that operating yield for an allocation. Next slide. So this, I'm not allowed to share detailed schematics from Reclamation, but this is kind of a cartoon schematic of the system. And it's meant to it's a little difficult to see, but to show the gradient. When you start at Kachuma, we're raw water from the lake to Laurel Reservoir, and then we continue on. It's goes in the Cater Water Treatment Plant. It's treated. It's boosted back into the South Coast Conduit. It goes through Ortega Reservoir, through the Sheffield Tunnel, then into Ortega Reservoir, and then on to Carpinteria Valley Water District system, and then Carpinteria Reservoir. So the interesting thing about the system, it was 100% gravity fed when it was built in the 1950s. So the whole system works by gravity. We open one valve at the lake, it all flows into all the reservoirs and throughout the systems, and everyone took the water, from the pipeline. In the 1980s, when Cater was installed, they lost about 20 feet of head to run it through the treatment plant, and so that has to be boosted about 20, 30 feet to get the water back into the hydraulic gradient to go down the South Coast Conduit. And so the key part right in the middle that I'm going to talk about is the Sheffield Tunnel, and it's interesting for a number of factors, but just kind of knowing where it is in the system is important. So next slide. So the original design in 1949 that Reclamation came up with, and that the Interior Secretary of Interior approved, and then the county went into contract with. The plan was to run the South Coast Conduit through APS and come back around to Sycamore Canyon, or back into Montecito, but that's through the Riviera. And at the time, the city of Santa Barbara wanted the Reclamation to look at an alternate route to not go through the Riviera with the large pipeline, because it had eminent domain, properties for the pipeline easement. So Reclamation did that for kind of political versus economic reasons. And so the pipeline was shortened by about 7,300 feet. It's a more straight route to go through the Sheffield Tunnel, but it did require the tunnel to maintain gravity flow. And it overall increased the project cost by about $560,000, which would be about $14 million today. So next slide. So you can see the Sheffield Tunnel basically starts just east of the Santa Barbara Tennis Club. If you've gone kind of by the Natural History Museum or the Botanic Garden, kind of in that area. And then it goes underground just north of the Sheffield reservoirs, now Hoover and McLaughlin reservoirs for the city of Santa Barbara. And it comes out in Parma Park, which is the city of Santa Barbara Park. And then it generally goes down the 192, kind of on and off the highway. But it had to go through the 250-foot, basically, watershed divide. And so it's 6,000 feet long. There's two portals, one on the east end, one on the west end, and there's manholes in the pipe every 500 feet. So next slide. So one of the challenges is that it was constructed during the Korean War. And at the time during the war, most of the steel was focused on the war efforts. So to do a civilian project, you had to justify your use of steel, and you had to get a quota from the federal government to do a project. So in general, they're very careful on the steel they used for construction. So for example, I have 80 different types of pipe on the South Coast conduit on the upper reach, on the reach from basically the Tecolote Tunnel to Laurel Reservoir. And so it's all different sizes of rebar, different gauges of steel. Just to get, for this barrel depth, for this pressure, we need this amount of steel. So they're very careful with the steel that was installed to maximize the use for the Korean War. That is a challenge because they, focused on ways they could reduce the amount of steel they used during construction. Next slide. So just a little bit on the South Coast conduit, which is this main pipeline that COM operates and maintains. So the first 10 miles of it coming out of the Tecolote Tunnel, it's a precast concrete cylinder pipe. So it's 48 inches in diameter on the inside and 6 inches walls on the outside. So it's basically a 5-foot diameter pipe. And it was cast in precast concrete forms with a steel cylinder and then basically two curtains of rebar, things of rebar, sheaths of rebar around the pipe. And it's generally only 16 foot long in its segments. The stretch from Lauro to Carpinteria, it ranges from 36 inches to 27 inches, and it's on the drawings, it's a modified pre-stressed cylinder pipe, but it's a bar wrapped pipe. But it's basically a steel cylinder wrapped in steel bar, and then it's coated with mortar on the outside and coated with mortar on the inside. So it wasn't cast in a form, it was coated with mortar. And then the final type of pipe we have, next slide, Billy, is the pipe that's in the Sheffield Tunnel. So it's a centrifugal concrete pipe, and it was cast in a form on the outside, and then it was spun, and then it rotted on the inside. But it's basically like a storm drain pipe. It's reinforced concrete pipe. And the other two types of pipe, it has a bell and spigot joint. This basically has a double spigot joint with a steel band around it. So the other type of pipe, it can only come out one way. In the Sheffield Tunnel, the pipe can come out kind of from the ring from both sides with the two gaskets. So next slide. The other challenge we have is it was built as economically as possible. So it's a 6-foot diameter horseshoe-shaped tunnel with this 30 ID diameter pipe inside, and then 3-inch concrete walls on the pipe for a total of a 3-foot diameter, 36-inch pipe. So it's really cramped to go in there and work and do inspections. And it took them a little under 2 years to construct the tunnel and the pipeline. So next slide. And the other challenges we have is once they built it, they had temporary construction easements, which they allowed to sunset, 3 years after the project. So they had large areas to work on the tunnel, and then they gave up those easements. So our current access on the west portal, they basically put it right adjacent or in a creek. So one wall, we have the windows sealed so the creek water doesn't get inside the tunnel. And it basically, the creek flows, right by one edge. And then the other edge we have to hike to in a park. So they didn't leave good access for us to operate and maintain the tunnel. And then you can see on the photo on the right, it's a challenge to inspect and go into the tunnel. You basically have to crouch and sidestep. You can't walk normally for about a mile to inspect the pipeline. Next slide. So we did inspect the pipeline in 2025. The previous inspection we did was in 2012. So generally every 6 or 7 years, the reclamation does these tunnel inspections. In 2018, we inspected the Tecolote Tunnel. We had issues with the Tecolote Tunnel inspection. We had some heat stress issues, so reclamation did a stand down on inspection. So we missed the Sheffield Tunnel inspection in 2018. So it came around again here in 2025, and we went in with 5 people. I was one of them, and then one person from reclamation, and we had Flowers and Associates or 2 people from Comb, 1 person from Reclamation, and 2 people from Flowers and Associates were the engineers that went in for the assessment. And none of the joints had been, formally assessed and individually categorized. So on this inspection, we numbered each joint according to the record drawings, took pictures, I think 6 or 7 pictures of each joint, and did a assessment of them. And so overall, we had 6 different conditions on these joints. There's 61% of them were in good condition. We didn't see any issues with the joints at all. 10% had minor hairline cracks. 14% had moderate cracking. And then the last 15% is where we're seeing a lot more issues. So 10% had severe cracking. 4% had the mortar splitting off the steel rings that make up the joint. And then 1% or 7 of the joints looked like the steel ring was compromised. And so that steel ring is kind of what holds the water in, except for the mortar on the inside of the pipe. So we're concerned, Reclamation's concerned that, the pipe could leak imminently within the tunnel. Next slide.
Joel, do you know if, so there no history of leaks previously, and if there was, it seems like with the way that the pipe was in the tunnel, it's hard to get to the bottom of it to even do any kind of in situ repair. Is that?
Yes, that's a challenge that I'll get to, but we do measure the tunnel intrusion once a month. So we measure what flows out of the tunnel. So there are some leaks into the tunnel from the outside. The groundwater goes into the tunnel and it drains along the floor. We measure that, and we measure the chlorine residual. And so it's generally been, 7 to 9 GPM ever since I've seen records of it. So we've kind of had this steady groundwater intrusion, and we're not picking up a chlorine residual. So we sometimes get 0.01 or 0.02, but that could be manganese. Manganese can appear to be chlorine, and we don't have the reagents to knock the manganese down, but sometimes it can look like chlorine. So it's hard to say, but if we had a leak, we'd see that intrusion increase, and we'd find residual in the water. So we do monitor the leak that way. So up to this point, there's no known leakage of the pipeline.
Okay, thank you.
And then what causes cracking on the pipeline? The one thing we have, there was an inspection done after the Glida earthquake, which was in August 1978, and that was a 5.1 magnitude earthquake. So that's the largest earthquake that the Kachuma project's experienced, since it was constructed in the 1950s. Prior to that, in 1925, I think most people know about the Santa Barbara earthquake. I think that was just under a 7, high 6 magnitude earthquake. But after that earthquake, they found there's a 1/4-inch displacement at various points, which I think would be on these joints, the cracking of these rings. And most of the cracking is near the portals, and near the deepest part of the tunnel, there isn't as much of this cracking. And a lot of times earthquakes there's more movement near the surface, and then as you go deeper, there's less movement. Kind of like waves on an ocean, the way you don't feel the waves underwater. Next slide. And so following this inspection, Reclamation gave us another Category 1 recommendation. So with the cooperative agreement, we got rid of our last Category 1, but now we've gotten a new one, and it's to develop and implement a plan to correct the deficiencies of the joints in the Sheffield Tunnel to prevent the failure. So this goes up to Washington at the federal level, and they ask for updates every 6 months on the progress that we're making. But basically, we've laid out 8 steps we're kind of working concurrently on. I'm going to go over, like 4 of these steps that we're currently working on. But the basic steps are, what's our plan in an emergency if we have a break right now, and can we improve our response time? I think it might take us 10 to 14 days to fix a leak right now. Can we get it down to 6 or 7 days with having equipment on hand and pre-prepping things? And then when I do a shutdown, we need, if we have a leak, I need good isolation points at the west portal and the east portal. Right now, Sheffield Control Station has a lot of old valves, and I can't get good isolation on that. And then east portal, if I was able to isolate there, we could get some water from the city of Santa Barbara into the South Coast conduit and feed Montecito and Carpinteria. And then any design that we have, we want to be cognizant of the impacts on the hydraulics of the pipeline. So originally, the design was for 14.2 million gallons to be able to flow through the pipeline to Montecito and Carpinteria. Right now, Cater can only get about 12.5 million gallons. And we think we know with some of the improvements we want to make, we can get that higher, restore it to basically the design capacity. That would be super helpful if there ever is a fire. That's when we really need to flow, as high as possible to get the water to where it needs to go. So adding, if we can add another 1 or 1.5 MGD, it could be helpful in these high demand periods. And then we're working right now with Flowers and Associates on, what is the long-term solution of this pipeline? How do we repair this pipeline? And then the big challenge we have is environmental compliance. How do we get into these portals now to fix it? And then financing, how are we going to finance this? We did apply for an IIJA loan. And Janet, I don't know if I'm forgetting the acronym off the top of my head, but it's through the federal government. I think we can get up to a 35% cost share on it. So we did do that application, and then implementing the project, doing that long-term repair. So we're not at, we're at steps 1, 2, 3, and 4 right now is what we're currently working on. But we're kind of in the future, in the next couple of years, we'll be getting to these later steps. So next slide. So the emergency contingency, right now, the current plan would be to install an internal joint seal into the pipeline. So we did this at Ortega Reservoir in 2021. We have the exact same pipe. It runs from the Ortega Reservoir to the Ortega Control Station. There's 700 feet there as well. We had a crack where it connected to the control station, and we were able to first install an external repair clamp on it, go back into service, plan the repair. 2 or 3 weeks later, we came in and we put this internal seal on the inside of the pipe. But it's basically a rubber sleeve, which would go beyond the crack, and you use stainless steel bands from the inside with a hydraulic press to seal the rubber sleeve against the walls of the pipe. And so there's a Hydrotite or Weco seal. The challenge is someone has to crawl in that 30-inch pipe, and you might have to crawl 250 feet. Each manhole's 500 feet apart, so the furthest you'd crawl would be 250 feet. But you're doing a confined space entry for a tunnel and then another one into the pipe to do the repair. So it's really complicated, risky repair. But that's the best, we know that works. That's probably what we'd try to do if we did have a leak in the pipe and the immediate repair. We do have 3 of these seals. We have them in stock. We did bring a contractor out from Pennsylvania that puts in these seals when we had the leak last time. Next slide. And so the key thing on these projects on the hydraulics, so as I mentioned before, the water's boosted in the South Coast conduit from Cater Water Treatment Plant, and then it goes into Sheffield Tunnel. And the key is it has to go over Barker Pass, which is the high point in the system. And Sheffield Tunnel is just below the elevation of Barker Pass. And then once it's over Barker Pass, it'll flow into Carpinteria or Ortega Reservoir. And then from Ortega Reservoir, then it can be released to Carpinteria Valley Water District. So the challenge is right now, if I have a break in the Sheffield Tunnel pipeline, there is an existing intertie, the Stanwood intertie, on Sycamore Canyon Road, downstream of the Sheffield Tunnel. So the city of Santa Barbara has a separate water system through the Sheffield Lift Station to Hoover and McLaughlin reservoirs that can feed over, into the same area where the South Coast conduit is. And we have an 8-inch intertie coming into the South Coast conduit that Montecito put in during the reservoir cover projects. And so if we had a way to seal between the intertie and the tunnel, we could at least get some water flowing to Montecito and Carpinteria if we had a break in the line. Right now, if we activated the intertie and we had a break, all the water wouldn't make it over Barker Pass. It'd flow backwards and continue to leak out of the leak we have in the tunnel. Next slide. So this is going over the projects we currently have in our budget for this year that the Combs Board is currently reviewing. So one is to replace and rehabilitate our control station at Sheffield Control Station. And so all of our valves in this control station are 75 years old. We haven't replaced anything since it was installed. we can't fully isolate the control station. When I've done 2 shutdowns in the past, I've had, anywhere from 30 to 40 GPM getting past the valves. So the problem is the valves, there's mineralization over time, tuberculation. So the seats on the valves can't quite fully close, and you have water that leaks past the gates. And then if I have someone in the pipe, per OSHA regulations, I need a double block and bleed. I need to have a full, isolation, 2 isolations with an empty pipe between those 2 isolation points. And so when we currently only have 1 isolation point in the pit on one of the bypass lines. So when we do this rehabilitation, we'll be able to have a double block and bleed at the station. And this will allow the city of Santa Barbara to keep in operation to Sheffield Lift Station while the work is being done on the Sheffield Tunnel pipeline. So we have all the parts. We have a contractor in place. It's Tira Contracting. I was hoping to do it in April, but it just got too warm. So we're hoping to do this in November, and we'll rehabilitate this control station. Right now, one of the flow restrictions we think is a meter that we have. We have a 30 by 14 inch Venturi meter with a butterfly valve in the middle of it. So that water is really constricting down, then it has to expand outward. And so we're replacing that with a full bore magnetic meter. And that we think is going to help us with some of the head losses that we're seeing and the flow reductions that we have on the pipeline. So we'll get that fixed, and we'll see what that does. So that's one project we have this year. Next slide. And the other project we're working on is an isolation valve by the east portal. So if we can get an isolation valve in there, then we can get water flowing through the inner tie and at least have some water flowing to Montecito and Carpinteria during the break. And then also if we have a long-term repair, we can flow through that inner tie and get some water down to Montecito and Carpinteria. And so this is the La Mirada valve. These are photos from that project from the cooperative agreement back in 2021, but it's a fairly complicated process to put an isolation valve in the South Coast conduit. You have to find the pipeline, chip off the mortar. There's the bar wrapping, you have to remove that. And then you weld a wrapper plate around it. And then if you do a tap, which we did and will likely do, you have an outlet on the pipe, and then you have to hot tap through that outlet. So you put a valve on that outlet, a tapping machine cores out a coupon, and you pull that out. And then you can either block the line and do a line stop and a bypass. And then once during a shutdown, you can remove the section of pipe in between the where you've done those taps, and you can weld in a flange, and then you can install the valve. So it's a fairly complicated, highly technical process, but we've done it recently. We have the same engineers that did this valve, which was successful, Flowers, working on the design for the east portal line valve. And the larger question, what is the long-term solution? So I'm not presenting that here. We are working on that with Flowers and Associates. I haven't presented, the full details to our COM board yet on what the options are, but it could be anywhere from, do we just do a bunch of these internal seals inside the pipeline and, 20 or 30 of them maybe to get these bad joints, or there's options to pull a liner through the pipeline and expand it, and a semi-structural liner. The challenge with that is no one's ever done, I think, a 6,000 foot long liner and 30 inches in diameter. So the size and the length there's been shorter segments with larger diameter, but no one's done this size and length of pipeline before. And the challenge is we can only get in at the east and the west portal, and we're really access constrained. Or do we need to pull all the pieces of pipe out and pull a new pipeline in? If you look at construction, that could be a 3-month, 2 or 3 month process. So how does, the water districts have enough water during that time if we had to replace the whole tunnel in the pipeline? But those are all options, that we're evaluating at this time. But I'd like to say, the CAP project and the Casitas Intertie project, those projects that Carpinteria Valley Water Districts are doing, allows the water district to rely on local supplies and not be as dependent on the South Coast conduit. And so for this, vulnerability that we have here, it's, another reason to, do these projects that provide more alternate supplies and local supplies, because our infrastructure is aging and we're going to have to replace it, and we're going to need some longer term shutdowns in the future to keep the water flowing to where it needs to go. So that's all I have on the presentation, but I just wanted to we have a hard challenge up ahead, but we're incrementally working through it, and the staff has been great over the years working with Brian and Bob, and we've worked with the current general manager quite a bit too. So we're looking forward to working with Carpinteria on this hard problem, but it's a difficult one.
Any questions?
Joel, thanks for the presentation. For everybody's benefit, when I first came on to COMB in the transition, Polly made the point to really pay attention to this part of the infrastructure. So I felt like I owed it to the board to have them come in. So that's why we're going through this today. And, I think a couple things jump out to me. One is, this is a lot of smart people doing really dangerous work. So safety is a big element of this going through, and it's managing risk in the end. I think that last point was important about how the other strategic projects relate to our ability to deal with the aging infrastructure. So, I think we've got a really solid strategic plan in addition to the minutia of these individual projects, because there's infrastructure improvement projects that COMS has. It's a really long list, and these are just a couple of them that are really at the top of the list. So it's important work. Thanks.
Thanks a bunch, Patrick, and also Joel. So just to clarify then where we are now, and as you went through all those slides, it all came back to me. So thanks for that refresher. So we're talking to Flowers now, Joel and Janet, about a variety of menus from aggressive to, okay. Thank you.
Yep.
Thank you.
The challenge we need is to do a camera inspection of the inside, is what we need to do to really narrow down, can we line it? Is that an option? Or is there some deficiencies in there that we really need to think about a full replacement? But being able to rule out, a liner versus a replacement, I think is the big question.
Thank you.
Joel, thank you. Great presentation. And you guys did tremendous work on the cooperative agreement for us. And I look forward to hearing your success on fixing this problem.
That's the easy way.
Thank you.
Anything else?
Nothing.
Yeah, Joel, thank you very much. Very, very informative, very helpful. Thank you.
Get well.
Yeah,
well, we need you.
right. You got a big job ahead of you. So that moves us to number 8, director reports. 8A, CCWA regular meeting, April 23rd, 2026. Kelly?
Yes, so that meeting, CCWA adopted its budget, and they are starting a salary survey, which they do every 5 years. But the main highlight of that board meeting was Ray Stokes' retirement. So that was his last board meeting, and there was a wonderful turnout. I was really happy to be there and see all the people from really the whole history of CCWA, from the first general manager and all the way through, showed up. So it was really a great celebration. So.
Thank you. Then we got item number 8B, COMB regular meeting, April 27, 2026. Patrick?
Yeah, the essence of it was what we just heard, but there were some other agenda items that are obviously important. The third quarter financial review, expenses under budget, I think is the highlight there. Also talked about the IAP, again, sort of all this stuff mixes together. So the North Pearl elevator was mentioned briefly in this last presentation. That's another high priority safety, infrastructure related thing that needs to be fixed, sort of at that same level. And there's lots of fish out there. I guess that would be the last comment.
Thank you, Patrick. Then we got item number 8C, Coastal Housing Partnership, April 15th, 2026, myself. And I just wanted to give everybody a little recap. It was actually a very well-prepared presentation by John Peterson from the Coastal Housing Partnership. Most of the employees were there. Basically, Coastal Housing offers discounts for rental housing to employees, and also helps or has discounts in place to purchase homes. What was interesting was with Coastal Housing, if you have enough income, they're able to help you with putting a second mortgage on a purchase, as long as you can afford to pay for that. And then the buyer or the employee would have to come up with 1% of the purchase price of the home. And one thing that was somewhat interesting is on mobile home, they're not able to finance regular mobile home parks, but they are able to finance owner operated or owner-owned mobile home parks, which was interesting. And again, that's probably the most affordable home on the Central Coast if there's a few of those available. And it was a very good presentation, but I also felt all our employees were there, and I think it was very well received. It was very productive and very constructive. So, thank you guys. Actually, there was one more thing I'd like to add. During the last couple of weeks, Kelly made 3 presentations to the Carpinteria City Council members. There was 3 separate meetings because we need to keep them separate. And again, it was a very good PowerPoint presentation Kelly put together on basically what the district does, how we do it, and all our information and everything else. And I also felt it kind of built a better relationship with the district and the city of Carpinteria. I thought it was very productive also. Then we move on to item general manager report, number 9, none. Then we go on to closed session items, 10A, conference involving a joint powers agency pursuant to paragraph 1 of subdivision A of Government Code section 54956.96, Consumer Operation and Maintenance Board. Discussion will concern conference with legal counsel, Government Code section 54956.9 D2, potential litigation, potential exposure, name of local agency representative on joint powers agency, the JPA board, Patrick O'Connor, additional attendees, Janet Gingras, and JPA general manager, William Carter, JPA counsel. Closed session, item number B, conference with real property negotiator, property 4701 Foothill Road, Carpinteria, California, 93013. Agency negotiator Kelly Dyer, general manager, negotiating partner Edward van Wingerden, under negotiation, easement price and terms and payment, and I'll step out and Casey will handle that one. Then we got item number C, closed session, public employment pursuant to Government Code section 54957, title Operations and Maintenance Manager. D, closed session item, conference with labor negotiating pursuant to Government Code section 54957.6, agency designated representative, general manager, unrepresented employee, operations and maintenance manager. Item number E, closed session, public employment pursuant to Government Code section 54957, title Operations Advisor. Item number 10F, closed session, conference with labor negotiating pursuant to Government Code section 54957.6, agency designated representative, general manager, unrepresented employee, operations advisor. Then we got 10G, closed session item, public employment pursuant to Government Code section 54957, title General Counsel. And then we got 10H, closed session, conference with labor negotiator pursuant to Government Code section 54957.6, agency designated representative, general manager, unrepresented employee, general counsel. So we're going to go in closed session. And I think our guest will come with us.
Recording stopped. Recording in progress.
Okay, we're back in open session, and then for items number 10A, B, C, D, E, F, G, H, no reportable action. Then we go on to item number 12, consider dates and items for the agenda for Carpinteria Valley Water District Board meeting of May 27, 2026 at 5:30 PM. Carpinteria City Hall, 5775 Carpinteria Avenue, Carpinteria, California, and we are adjourned.